We have two main types of bipolar transistors, the NPN and the PNP type. The two transistors look nearly identical, so we need to check the part number to tell which is which. Now, with a transistor, we have 3 pins, labeled E, B, and C. This stands for the emitter, the base, and the collector. Typically, with these resin body type transistors with a flat edge, the left pin is the emitter, the middle is the base, and the right side is the collector. However, not all transistors use this configuration, so do check the manufacturer's datasheet. Pure silicon has almost no free electrons, so what engineers do is dope the silicon with a small amount of another material, which changes its electrical properties. We call this p-type and n-type doping. We combine these materials to form the p-n junction. We can sandwich these together to form an NPN or a PNP transistor. Inside the transistor, we have the collector pin and the emitter pin. Between these, in an NPN transistor, we have 2 layers of n-type material and 1 layer of p-type. The base wire is connected to the p-type layer. In a PNP transistor, this is just configured the opposite way. The entire thing is enclosed in a resin to protect the internal materials. With an NPN transistor, we have the main circuit and the control circuit. Both are connected to the positive of the battery. The main circuit is off until we press the switch on the control circuit. We can see the current is flowing through both wires to the transistor. We can remove the main circuit, and the control circuit LED will still turn on when the switch is pressed, as the current is returning to the battery through the transistor. In this simplified example, when the switch is pressed, there are 5 mA flowing into the base pin. There are 20 mA flowing into the collector pin, and 25 mA flowing out of the emitter. The current therefore combines in this transistor. With a PNP transistor, we again have the main circuit and the control circuit, but now the emitter is connected to the positive of the battery. The main circuit is off until we press the switch on the control circuit. We can see with this type that some of the current flows out of the base pin and returns to the battery. The rest of the current flows through the transistor and through the main LED and then back to the battery. If we remove the main circuit, the control circuit LED will still turn on. In this example, when the switch is pressed, there are 25 mA flowing into the emitter, 20 mA flowing out of the collector, and 5 mA flowing out of the base. The current therefore divides in this transistor. I'll place these side by side so you can see how they compare. Transistors are shown on electrical drawings with symbols like these. The arrow is placed on the emitter. The arrow points in the direction of conventional current, so that we know how to connect them into our circuits. Okay, that's it for this video, but to continue learning about electronics engineering, click on one of the videos on screen now, and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, LinkedIn, Instagram, and of course the engineeringmindset.com.